Hello everybody! On today's episode of Do-It-Yourself Chemistry Callie, we will be learning about electron orbital diagrams, Hund's rule, Pauli's exclusion principle, and electron configuration. Also, my good friend Napoleon Nitrogen is going to explain general periodic trends. Later in the show, we will have 4 special guests. For the first segment of DIY Callie, I am actually calling on my dad, Dad Dysprosium, to explain electron orbital diagrams.
Orbital diagrams are written as platforms showing the increasing energy. Each platform represents an orbital that can hold just 2 electrons. The 1s orbital is the lowest energy spherical orbital that can hold the first 2 electrons. 2s represents a much higher energy spherical orbital with the next 2 electrons. There are 3 platforms for 2p because there are more orbitals within the 2p shell. We call these dumbbells. Notice that Callie is filling the diagram for the element nitrogen. Also notice that she is filling the orbitals up in a certain order. She's going to explain this now, and thanks for watching DIY Orbital Diagrams with Dad Dysprosium.
Thanks, Dad. Now it's time to take a journey to my chicken coop to learn about Hund's rule. Hund's rule states that the most stable configuration for electrons is to have unpaired electrons at the same energy level rather than pairing up electrons and leaving empty orbitals. Basically, it's saying electrons spread out before pairing up. It's like chickens in a nesting box. Each chicken wants its own box before trying to squish 2 chickens in one box. Isn't that right, Susie? That's right. Next is Pauli's exclusion principle. The Pauli exclusion principle is the quantum mechanical principle that states that 2 identical fermions cannot occupy the same quantum state simultaneously. What was that? Okay, so it's basically saying electrons have 2 different types of spin. One is like a twirl, while the other is like a somersault. Just like if you have 2 twirlers or 2 somersaulters in the same room, it just doesn't work. Now that we know some rules and regulations on orbitals, I want to explain to our viewers how to draw an electron configuration for nitrogen. You start with writing the energy level, 1s. Then you count the number of electrons that are on the platform and put that in the superscript. For s orbitals, a 2 in the superscript is a full orbital. For p orbitals, a 6 is the highest number in the superscript. This is because there is 3 platforms and 3 times 2 is 6 electrons. Now, let's turn to Napoleon Nitrogen to explain some periodic trends. Hi, I'm Napoleon Nitrogen. And as you move across the period on a periodic table of elements, the atomic size actually decreases. This is because the number of protons increases, which draw in the electrons further. As you move down the table on periodic table of elements, it's called a family. Like my family? No, God. As you move down the column on a periodic table of elements, the atomic size increases because the orbital size is increasing. Now give me some thoughts. Now it is time for our 4 special guests. I'm helium, and I am above nitrogen, like higher, but in the same family. This means my atomic size is smaller because the 1s orbital is smaller than the 2s orbital. Oi! I'm Cowboy Carbon, and I'm to the left of nitrogen, but I'm in the same period. This means I have less protons than a polonium to draw in my electrons, therefore making me bigger than nitrogen. Hi, I'm on oxygen, and I'm to the right of nitrogen. But you see, I have more protons drawing in my electrons. So that means that I am much smaller than nitrogen. But I have a big heart. I have a big heart. Ha! I'm Puff Daddy Phosphorus, and I'm below nitrogen. Yo. But I'm in the same family. Thus, my atomic size is larger because the 3p orbital is bigger than the 2p orbital. That's it. Thanks for watching DIY Chemistry Callie. See you later.
Show you incredible things, magic.